Okay, today we're going to start taking a look at limits. And a limit is a dependent variable answer. Most of us think about that as a y value or something that comes out of output, that kind of thing. You just like looking at me laugh? Oh, weird. And so we're going to talk about some vocabulary with that, and then we're going to do a couple of example problems to help you out. So the word approach means something that you're getting closer to. Nice. Okay. So something you're approaching is a value you get closer to. And the limit is a value, usually we talk about it as a y value, that your equation gets closer to but usually never reaches. So a limit is a value. Usually we talk about it as a y value. It's an independent variable that you're getting closer and closer to but never reach. For example, if I was standing at one end of the room over here and I talk about, hey, this room is 40 feet across, and I walk halfway. So I walk halfway, and now I've walked 20 feet towards the other wall. That's halfway. Let's walk halfway again. So I walk halfway, and now I'm 10 feet away from the wall. Let's walk halfway. Now I'm 5 feet away from the wall. Walk halfway, 2.5 feet away from the wall. Walk halfway, 1.25 away from the wall. You keep walking halfway. And every time you walk halfway, the distance that you're traveling is smaller and smaller and smaller, but you never actually touch the wall. So you never actually get to the 40 feet, but you're getting really close to the 40 feet. That's the limit, 40 feet. That kind of a thing. A shifted geometric sequence is like our regular geometric sequences. So it's recursive and geometric, but after we multiply, we also add or subtract a number. For example, maybe I would have un equals un minus 1 times 1 minus 0.25, and then after I get done doing that, I add 15. So the shifting part just means at the end, you have this extra little thing on there. Add or subtract a number. So if you ever see that phrase, shifted geometric, all that means is do what you've been doing already, but in the end you have to add or subtract something. So it's a recursive and geometric equation, which means that we're multiplying a number, but afterwards we also add or subtract something. Questions so far on the vocabulary? Okay, let's try an example. Sometimes when we see equations, there are multiple ways to approach things, and Some of you may do one thing first and I may do something different. We both could be right, no big deal. In this investigation, they talk about a chart being the first step, but actually, I guess what I would do is I would instead talk about it a different way. I would talk about it the way I'm familiar in my calculator. I would write an equation first and then try to fill out the table. So in this particular example, they talk about the human kidneys hold about a liter of liquid. And in this liter, you're filtering all your impurities out, and let's say about 16 milliliters of medicine is brought into your body. So you get a pill, a shot, something, and you do not repeat the dose. That means it's one time, you take the medicine, you're done. Let's say you filter out, your kidneys filter out 25% of that medicine each day. So every day, 25% goes away. What we're going to do is we're going to talk about what does this mean long term for us. So step 1 says fill out the table, but I'm actually going to go to step 2. I'm going to look at what about this recursive formula. So we always talk about where do we start. And in this particular case, we're starting with maybe day 1, or the starting day, being 16 milliliters of medicine in your body. And then each subsequent day, which we've called the UN thing in our calculator, we have the previous day's amount, which was the UN minus 1 thing, and then we multiply by what's going on. Since I'm reducing my body content medicine by 25%, I would multiply by 1 minus 0.25. Some of you may choose to write down that you're actually multiplying by 0.75, but I've told you in the past that I think it's oftentimes good visually to see what's going on. This was a reduction of 25%. Is it wrong to multiply by 0.75? No, for sure it's okay. But this visually tells me what happened, reduction of 25%. So go to your calculators, type this in, let's take a look, see what happens. Let me grab my calculator. Actually, I'll just grab the one that's from the computer while you're typing that in. And since you see a U1, that means that that first number is a 1. That also means the starting value was 16. So if I go into my y equals, this number up here, the starting value is 1, the first value that is. Down below, when I'm looking at the equation, the u and the n minus 1 thing never change. I have a 1, bless you, and it's going to be minus 0.25 in my case. Now if you're just multiplying by the 0.75, that's fine as well. And then my starting value was 16. And then if I go into my table to take a look and see what's going on, now we can fill out our table, which was the next part. So let me look at my table set, see what happened here. I'm going to go with start at 1, go up by 1, and do auto so I can just look at my table. So table set, second window, and then 1, 1, auto. Go look in our table, and these are the numbers they're talking about. Day 1, when I inject the medicine, I have 16 milliliters. Day 2, I have 12. Then I have 9. Then I have 6.75, 5.06. So now let me go back to my page over here. And as I fill this chart out, day 1, 2, 3, 4, and 5, 16, 12, was it 9 after that? 6.75 and 5.06. Questions about any of that?